Welcome to this second presentation on the Cambrian of Morocco. Part 1 included an introduction providing an overview of the distribution of Cambrian rocks in Morocco in regional, geotectonic as well as stratigraphical context, followed by some Cambrian research history and a short characterization of the Cambrian in the western Meseta region and in the Tamlet Inlier. This part 2 will now deal in some detail with the Cambrian rocks distributed in the Anti-Atlas and in the Western High Atlas ranges, which are perhaps the best preserved, most fossiliferous and the best studied of the Cambrian rocks in Morocco. This sketch map presents a crude overview of the geotectonic units distinguished in Northwest Africa, and the Anti-Atlas block is a slice dominated by Neoproterozoic and Paleozoic rocks. The Cambrian rocks belong to a latest Ediacaran through Silurian depositional scenario which took place in a relatively shallow epicontinental sea. The paleogeographic setting is best described as a relatively narrow west-east stretching sedimentary basin termed the Sousse Gulf, with transgressions commencing from the west. A glance to a satellite photo of the snow-covered High Atlas and the Anti-Atlas south of it shows that the Anti-Atlas is among the best regions of this planet with the largest outcrops of Cambrian rocks, and one could virtually walk only on Cambrian rocks from the Atlantic coast in the southwest to where the Jebel Ugnat region of the eastern Andes is finally covered by young desert sediments in the northeast over a distance of more than 500 kilometers. Let's zoom in and have a closer look to the area in the central atlas marked by the yellow rectangle here. This satellite photo shows part of the central Anti-Atlas and nicely illustrates how single stratigraphic units, down to formation and members, can be recognized even from space. I have marked just a few units, like the Adudu Formation and the Jebel Wawarmas Formation, which I will explain in some detail in a few minutes. The Cambrian in the High Atlas and Anti-Atlas regions were first studied in the 1920s and 1930s in studies reviewing relatively few localities and small localities of fossil discoveries, such as the first study of Lower Cambrian archeocytes at Sidi Musa Daglu at the Atlantic coast south of Agadir by Jacques Burckhardt in the late 1920s. Louis Neltner published the first study which put Cambrian fossil localities into stratigraphic and depositional framework in 1938. Neltner was the one to put some focus on localities with lower Cambrian trilobites in the western Anti-Atlas, such as the Isafin syncline and Amuslek, which later became the seedlings for a comprehensive stratigraphic framework. Pierre Huppé started systematic and biostratigraphic research in 1951, which led not only to a systematic study of the lower Cambrian trilobites of mainly the western Anti-Atlas, but also to a biostratigraphic zonation for the lower Cambrian, and this is the first detailed biostratigraphic subdivisions of the Cambrian in any region. Here the biostratigraphic and chronostratigraphic framework. The second column from right shows Huppé's original trilobite zones, subsequent studies and the discoveries of additional trilobites in other areas of the Anti-Atlas and High Atlas led to a considerable modification of this general context, and the updated biostratigraphic zonation is shown here in the right column. Owing to the fact that these trilobite zones indicate a chronostratigraphical subdivision, the Cambrian has been subdivided into regional or subcontinental stages and series. The Moroccan Cambrian has contributed to a standard subdivision for Western Gondwana, which is shown in the green column. To the left is the global chronostratigraphic subdivision into stages and series. The Ternovian and Series 2 correspond approximately to the early Cambrian in traditional sense. The Merovingian corresponds approximately to the Middle Cambrian in traditional sense, and the Furongian to the Late Cambrian. In fact, Upe's original zones here in blue were believed to be Lower Cambrian. However, the range of the Paradoxides in broad sense, marked here in green, corresponds to the traditional Middle Cambrian. The big leap recognizing rock succession in the Cambrian was achieved by Jean Joubert in the 1940s and early 1950s during his mapping activities in the Western Anti-Atlas. In fact, the seeds for this were the sections at the northern rim of the Western Anti-Atlas, such as Amagur, Amuslek, Tassimurt, and Tiyut, and the sections in the Isarfen syncline, all shown here in the red rectangles. Fortunately, sections such as at Amuslek or in the Isarfen syncline, shown here, were very fossiliferous and enabled to calibrate the trilobite zones of UP with the lithologic successions. The result was Joubert's reconstruction of the Lower Cambrian lithology, lithostratigraphy, and phasous changes. This reconstruction is a tremendous achievement for that time, even if we have to say that there are a number of reservations needed. Joubert assigned the entire succession shown here to the Georgian or Lower Cambrian, which in fact was not correct even at that time. The thicknesses given for some of the units are a wild guess and did not take into consideration the structural complications, so the 3,000 meters for the present-day Adudu Formation in the west, at the western margin of the Anti-Atlas, this is certainly way too much, but other thicknesses are probably too high as well. In addition, some of the phasous changes must be questioned. The sedimentary cycles shown here to the left are not correctly separated, and finally, some of the lithological units are in fact of different ages rather than lateral equivalents. What caused more confusion is that the boundaries and the content of the units underwent frequent small changes. Henri Hollard attempted an update for the monograph volume of 1985 and showed a rough compilation of the earlier concepts, which we see here. Unfortunately, he mostly used the same names again and in such a way produced further junior synonyms. I have been trying to get the situation into a robust scheme in 1989 and also explained the dichotomy between lithostratigraphical and chronostratigraphical units, which were often randomly used. As an example, the so-called série lit de vin of Joubert was clearly introduced as a lithostratigraphic term. The Talivinian or Talivinien, subsequently introduced by Joubert, was meant as a chronostratigraphic unit. So the Talivin formation is illegal for two reasons. First, it is a junior synonym of the lit de vin formation, and it is a homonym for a Talivin stage, which, by the way, does not make sense because the lower and the upper boundaries would be diachronous. A second example, the Great Terminaux is a detritic siliciclastic unit which was and still is in many cases also termed the Assyria formation. However, it turned out that several units believed to be lateral equivalents in fact represent short or depositional episodes, one on top of the other, and the so-called Asriel formation is therefore obsolete. The state of art in terms of lithostratigraphy of the Cambrian of the Atlas ranges is summarized here. To the left are the global and the West Gondwana chronostratigraphical units and the biostratigraphical units of the Anti-Atlas and Western High Atlas. The right half shows a strongly simplified spatial and temporal arrangement of the presently recognized lithostratigraphic units, with the western part to the left and the eastern margin of the Suez Gulf to the right. There is also an attempt to figure the lateral extra facies known from the Western High Atlas block. The precise temporal ranges of deposition are impossible to determine with any certainty where fossils as the primary age indicators are unknown, such as from the recessive detrital units that progress from the margins of the basin. Not shown are also the results of sub-regional block movements which created areas in which the quote-unquote Middle Cambrian Tatelt or Chibel-Wabermast formations transgressed directly on the Ediacaran or older basement rocks. A reconstruction of the shifts in depositional environments reveals numerous, mostly small-scale sea level fluctuations. The column here is for the western part of the Suez Gulf only. A number of regional block movements in the basin serves for a complication of the distinction between eustatic sea level fluctuations and epeirogenic crustal developments. If one sorts out these patterns, there is a sort of transgressional-regressional grand cycle recognizable for the lower part of the Cambrian and a second grand cycle for the middle to upper Cambrian. The lower Cambrian grand cycle can also subdivide it into third order cycles 1, 2, the middle and upper Cambrian grand cycle as well into 2 third order cycles. The lowest of these cycles coincides with the Tarodont group, which is in fact completely pre-trilobitic and thus Ternovian in age. The second coincides with the Tata group and with most of UP's trilobite-bearing Georgian. However, note that the start of the Féchat-Anterne group includes a transgressive blanket of siliciclastics which was formerly assigned to the Great Terminaux or the Asriel formation. The name Féchat-Anterne, by the way, derives from the name of the relatively low proximal ridges on the outboards of the southern Anti-Atlas, which are formed by the Middle Cambrian siliciclastic formations. The top of the succession is formed by only a few very limited outcrops of Upper Cambrian rocks with a few trilobites. It is clear that they do not show the end of the deposition, but rocks above them seem to have been removed by subsequent erosion before the Tremodosian erosion. This, by the way, is typical for the Cambrian successions of the Cadomian belt of West Gondwana. The Cambrian rocks rest disconformably on basement rocks, typically on the Ediacaran Ouarzazate formation. Intricate mapping or favorable outcrops, as shown here for a situation in the Jebel Ugnat region in the eastern Anti-Atlas, indicate a fairly complicated topography. This brings us back to a last preliminary remark before we start with showing all relevant lithostratigraphic units. The already mentioned block faulting in the Anti-Atlas and High Atlas is responsible for distinct differences in the local thickness of some formations. The situation is shown here in a very simplified sketch. The boundary between the Suez Gulf region and the Meseta Sea is marked by a thrust where considerable parts of Cambrian rocks are lost. As a result, distinct differences in lithostratigraphy and faunal composition can be seen between the two blocks. How much is indeed lost is difficult to know, but the cross-section on the bottom from north-northeast to south-southwest with Cambrian deposits in light blue certainly does oversimplify the differences. The oldest formation identified as Cambrian is the Adudu Formation. It was traditionally subdivided into a série de bases and the so-called calcaire inférieur, in English the lower limestones. The série de bases was subsequently renamed into Tabia member, which consists of extremely variable developed rocks, typically shales, gravelly sandstones and conglomerate, as shown here from the Western Anti-Atlas. The sandstone shows sedimentary features typical for shallow or coastal environments and perfectly fitting with the transgressional depositional setting. Several localities indicate sedimentary complications resulting from volcanic activities such as Neptunian dikes. Attempts to reveal reliable radiometric dates have failed to date. The two photos to the right show the situation, which is shown here in the sketch. There were some reports of Medusoid fossils from the member, which were used to indicate an Ediacaran age in present-day nomenclature. Similar specimens have recently been found in other localities, seemingly confirming the earlier assumptions. These disc-shaped fossils may represent some sort of Aspidella-like organismic remains and would indeed indicate an Ediacaran age. As mentioned, the Tabia member differs considerably in facies from locality to locality, and the member in the Western Anti-Atlas appears to be separated by a distinct unconformity from the overlying calcareous Tifnut member. In addition, the coarse-grained siliciclastic basal strata in the central Anti-Atlas, shown here, could simply represent, at least in part, a transgressive lack rather than being a lateral tongue of the true Tabia member in the Western Anti-Atlas. The Tifnut member is generally one of the most monotonous successions. It typically consists of thick-bedded dolomitic limestones in the Western Anti-Atlas, which may be cliff-forming, grading into dolomitic beds with siltstone intercalations. Deposition took place primarily under shallow subtidal to inter- and perididal marine conditions. The blanket of dolostones covers virtually the entire western and central Anti-Atlas. The topographic differences during the deposition resulted in dramatic lateral facies changes. Sedimentary structures are usually difficult to recognize, but they include cross-stratifications and other indicators of deposition on the shallow shelf setting, often with occasional subaerial exposure. Hence it is surprising that this calcareous member not only seems to accumulate such high thicknesses, but also that it appears to represent a surprisingly long time span. The thickness appears to vary quite distinctly from more than 1,000 meters in the Western Anti-Atlas to about 300 meters at the Algarara Massif in the Central Anti-Atlas. This map shows the enormous outcrops of the supposed Adudu Formation with a best guess of thickness. It is also an attempt to portray facies changes with a purely siliciclastic marginal belt shown here by the loosely stippled pattern. The densely stippled area is a best guess for the limits of the distribution of the Tabia member. The Lidevin Formation is another thick and widely distributed unit, but also difficult to study. The type section in the Teot section at the northern rim of the anti-atlas provides quite spectacular aspects. Almost all of the rocks shown in the foreground and the middle ground belong to the formation. In the far distance, you can recognize the Sus Plain and finally the High Atlas Range with some snow-covered mountains. The Lit de Vin Formation is composed of variably developed rocks. The name, which means in English red wine color, refers to the presence of reddish brown and purple shales, but there is a high amount of gray shales, gray dolomites and other lithologies as well, usually stratified in rhythmic patterns. The Teot section shows a complex interbedding of lithophases that composes about 180 autocyclic shallowing upwards parasequences. These reflect, of course, rapid changes in depositional environments. A gradual magnification of the succession reveals an eye-catching pattern of stacked cycles arranged to a complex cyclicity at different orders. Complete parasequences start on a flatting surface, followed by interbedded argillites and laminated carbonates, which are then overlain by stromatolitic limestones and or thrombolytic carbonates. Biohermal carbonates pass laterally into grainstones. Dolomitic, limy, marly and silted sediments were deposited under persistent low energy, shallow marine and relatively hypersaline conditions. The alternating lithophases reflect some combination of changes in siliciclastic input, salinity or climate, or small-scale sea level fluctuations. These conditions led to asymmetrical cycles or alternations that include tidal flat dolostones with cyanobacterial laminites and such indicators of hypersaline conditions as pseudomorphs after halite and anhydrite or gypsum. The evaporitic facies passes offshore into migritic, palloidal and oolitic limestones with stromatolite and thrombolite bioherms. This, of course, suggests orbitally forced changing sea levels. Nevertheless, such a simple explanation is hampered when one considers that the Lit de Vin Formation rocks are formed under shallow, partly extremely shallow marine conditions in which a complete record is difficult, if not impossible, to preserve. A seaward tilting of the present-day anti-atlas margin at the end of the Adodo deposition initiated a change in deposition. This tilting is recorded by a landward regression and resultant erosional contact of the Lit de Vin Formation with the underlying units. It also initiated the deposition of fluvial siliciclastics in the east, which cover a huge area and characterize the Tikirt member or Tikirt Formation. I will further discussing this in a minute. Seaward, the formation shows a change from peritidal carbonate to sublittoral shale biohermal limestone sedimentation with an increase of terrigenous detritus. The isopachs indicate distinct differences in thickness, with a reliable measured 950 meters in the Teot section and about 300 meters in the Ouarzazate region, and then less than 25 meters south of Jebel Saro in the east. A distinctly more calcareous facies development is seen in the deepest part of the basin in the western anti-atlas, whereas more shaly and thus more purple parts dominate elsewhere. The dominantly shaly facies of the Lit de Vin Formation is prone to tectonic deformation, which is recognizable by its particularly eye-catching style. Large-scale faults and parasitic second-order deformation structures create fascinating patterns, sometimes of partly high aesthetic quality. Such examples are best known from the southern flank of the anti-atlas region west of Tata. A regional special development can be seen in the central anti-atlas at the western end of the El Guara Massif, where a volcanic complex of alkaline chemistry is inserted or intercalated into planar laminated stromatolitic dolostones. probably of the uppermost Adudu and lowermost Lidevin formation. The rocks range from basanite, tephrites, trachyandesites, trachytes, and trachydicites to some alkali rhyolites and cyanitic explosive volcanics, and a large amount of these rocks in the distal parts are tuffs. The complex is easily recognizable even in satellite photos as this one. The position of the tuffs would enable an age assignment of the surrounding sedimentary rocks, but the radiometric datings performed on the Jebel Boho volcanics are less than reliable. The perhaps most significant is a 534 plus minus 10 million years age on the cyanide plaque of Jebel Boho, published by Ducrot and Lancelot in 1977. Another lithostratigraphic unit is sandwiched between the Lidevin formation and the overlying Igodine formation in the central and eastern anti-Atlas, and this is the aforementioned Tikurt member or Tikurt formation. Locally, it rests on the Jebel Boho formation, as here. It also interfingers with primarily the middle part of the Lidevin formation. This fluvially deposited formation consists generally of relatively coarse silicic clastics that reflect regression and terragenous input. Sedimentary structures seen in the Tikurt rocks are mainly cross-stratification and different types of ripple marks. The lower part of the Tikurt frequently has fluid and lode cast. Ichnofossils are known from the upper part of the formation, including Diplechnitis-type traces. You may have realized that stromatolites were mentioned in one of the previous photos for the Adudu strata. Well, in fact, stromatolites are not typical for the Adudu rocks, but they are frequent to almost abundant in several horizons of the Lidevin formation, and a few new forms have been named from those strata. Microbial mats, thrombolites, and stromatolites become then finally abundant in the lower part of the overlying Igodine formation, which consists predominantly of thick-bedded carbonate rocks and is thus cliff-forming in the Cambrian outcrops. The type section at Tiyut shows superb examples of dolomites with microbial structures typical for a restricted marine environment, slightly hyposaline conditions, and are typical for the lower and middle part of the formation. They characterize the restricted marine interval. Here is another example with stromatolitic structures overformed by diagenetic processes. The formation was formed under shallow marine conditions, locally under restricted circulation and relatively high salinity, as indicated by frequent low algal mats and stromatolitic buildups. However, the massive dolomitic carbonates at the base become increasingly calcareous upward in the southern anti-Atlas. Here is a photo from the upper part of the Igodine formation, the so-called Tiyut member. This is characterized by a high amount of dark limestones that feature more open marine conditions, such as oolitic or oncolytic limestones as shown here. The change between the lower member and the upper Tiyut member takes place fairly abruptly, and the normal marine limestones at the base of the Tiyut member served for suitable habitats of the typical normal Cambrian animals. This is a photo of precisely the lowest sampling horizon, which delivered the oldest known trilobites, not only from this section at Tiyut and entire Morocco, but probably also the oldest trilobites known from West Gondwana and among the oldest trilobites known worldwide. Just above this horizon are the oldest archaeocyaths, which are carefully studied by Françoise Dubrenne with the assistance of the husband Max. I'm just showing a few examples of thin sections of the species recorded to date. The image to the right provides an impression about the internal structure. Not only are 6 different species recognizable in this small sample, but some of the specimens are fractured, so that this is indeed an example of biohermal debris, whereas the Neoleucocytus cup in the upper left is completely overgrown by microbial algae. Volcanic activity during the Lower Cambrian is not restricted to the Jebel Boho volcano, but is in fact fairly widespread. However, ash layers are usually sparse or difficult to recognize due to the outcrop conditions. However, the Tute section enables a few high-precision radiometric datings which were published recently. Here you see a simplified section of the upper part of the Lidevin Formation, the Igodine Formation, and here the lower part of the Almus-like Formation. An ash layer in the upper part of the Lidevin Formation has now been dated several times with different methods, but our recent ID TIMS dating of zircons provides the most precise and obviously best age constraint with a 521 million year date of this horizon. This is in perfect accordance with 3 additional dates upsection with a maximum of 519.87 for a horizon just below the lowest and oldest trilobites in the section, and 2 ash layers with approximately 519 million years at and slightly above the base of the Almus-like Formation. These dates are interesting on a global scale because they prove that the purported ages of 520, 521 and 522 million years for the earliest trilobites in South China, Australia and other regions cannot be correct. I should also point your interest on the fact that the less than 1 million years between the base of the Tute member and the upper and lowermost Almus-like Formation can be subdivided into 3 trilobite zones, which places them among the best resolved by these animals. The proof for this: the lithologic column to the left is for the Tute member with all trilobite and archaeocyath horizons marked, but only a small fraction of the trilobites are shown here to give you an impression about the morphology of these animals. They belong generally to 2 systematic groups: the phallotaspidids, recognizable by the entire heads with genal spines figured here, and the bigotinids, all with marked oblique eye ridges. Both groups are best represented in Morocco, and they can be interpreted to characterize a distinct biogeographic province. The age determinations are relevant in respect to other data from the Ardutu through Almus-like formations, which made their way into international recognition. An author team published studies primarily on the carbon isotopic signatures from the northern slope of the western anti-atlas and put them into a global perspective. This here is a modified figure from the main publication in 2005. Important to know is that there are delta C14 signatures which seem to be recognizable on a global scale, which means that they reflect distinct changes in the seawater chemistry. This is a global correlation chart for the Cambrian, and the supposedly recognizable carbon isotope excursions for the lowest part of the Cambrians are marked here in the lower right. With the base or the basal Cambrian carbon isotope excursions at or slightly below the base of the Cambrian, the Tsuji or Sujiajing carbon isotope excursion, the Shichi or Xian2 carbon isotope excursion. Let's see in how far these excursions are recognizable in the Moroccan sections. Brown colors, by the way, indicate positive, blue colors negative excursions. So let's go back to the sections in the anti-atlas once more. There is a negative peak marked by the black baseline in the lower part of the Tifnut member of the Adudu formation, but this cannot represent the base event because that is marked by a positive and not by a negative peak. It is not tremendously sharp in the region, but it seems to be recognizable in all sections. The main study section of the Malouf group was the Wets Dust section close to Tiyut, where a very distinct positive excursion has been detected in the middle to upper part of the Adudu formation. An ash layer with this strata provided a precise age of 525.4 plus minus 0.5 million years. There's a distinct drop in the isotope values above, which appears to be present as well in the Tiyut section visible to the left. Nevertheless, this event indeed fits with the Tutsi event on a global scale. The 522 plus minus 2 million years age shown for a horizon in the upper part of the Tiyut section is the one recently remeasured to 521.06 million years. There are difficulties, however, with a purported positive carbon isotope excursion above this, interpreted to lie just before the onset of trilobites and archaeos. Such an excursion can be seen vaguely based on few data in the Tiyut section, but its lower extension is not known. The Wets Dust section does reach up only into the critical levels, so that only a positive trend across the Lidevin-Igodin boundary is recognized. And in the Talat Nissi section, some distance to the west, the peak sits below the Lidevin-Igodin boundary. This is a simplified map for most of the Tatar group, so including the Igodin through Isaphane formations in the western part of the basin, the Tislit formation on the eastern part of the basin, both surrounded by a detritical belt, which is actually not really well known, and the extra facies of the Lemdad formation of the High Atlas marked by the dense brick signature in the north. There are facies differences in the deeper part of the basin in the west, and two areas with a particularly high amount of carbonates are marked by the brick signatures. The Amuslek formation is one of the earliest recognized units, termed the série schisto-calcaire by Jean Schubert. Indeed, it is a variably developed succession of limestone and shale units. The typical field aspect in the western anti-atlas is shown here in this photo. The formation is a sequence of greenish purple or gray shales, often slaty, with intercalated limestones, the latter often containing archaeocyathon bioherms. The unit is widely distributed in the anti-atlas and ranges from about 220 meters in thickness at the Amuslek type section to about 40 meters south of Jebel Kisan. This photo shows the typical aspect in the central anti-atlas with the rhythmic changes between limestone beds and shale units. The limestone beds are quite differently developed. One typical facies is that shown here of archaeocyath microbial limestone, but true biohermal strata are relatively rare. The archaeocyath are again studied in detail by Françoise Debren. Here are three examples of species first described from the Amuslek formation. The limestones can be quite differently developed also as oolitic or peloid stones, as seen in the photo to the right. or as mottled limestones, partly with stromatactys type structures. The first thoroughly studied section of the Amuslek Formation lies near the village of Tassimurt, close to Tarodant. This was examined during a PhD thesis of a French student, Jean Abadie. He collected stratigraphically numerous trilobites and archeocyaths, which served as the basis of the biostratigraphic subdivisions by Pierre Huppé. Additional trilobites from the formation were collected by Louis Neltner at Amuslek, and this shows the holotype of these original samples of Abadie and Neltner, such as Phallothaspis typica in the upper right, Daginaspis ambrogii, the middle photo in the lower row, and the strange Desbichorgia rochi to the left. These are all specimens from the formations of the Amuslek and the Tassimurt section, featuring the classical specimens used by Huppé. However, even nowadays it is not a big problem to discover new species, such as this recently discovered trilobites to the right from the Tassimurt section. And even more than a decade ago, it turned out that there are strata in the higher part of the Amuslek Formation which keep unusually well preserved fossils in a small area stretching from Tiut to approximately 30 kilometers to the southwest. This is the first true fossil Lagerstätte from the Cambrian in entire Africa, just recently described. Here are two examples of trilobites with parts of their digestive tracts preserved. The paired black dots in the axis are midgut glands. In addition to the trilobites, there are of course all other kinds of normal Cambrian body fossils in the Amuslek Formation, such as brachiopod shown here. The left specimen is a very strange disc-like brachiopod with preserved delicate bristles and surface structure. Interestingly, soft parts are also preserved, here as bulbous structure forming a ring in the middle part of the valve. It is believed that they represent part of the lophophore on the internal, which are pressed through the demineralized valve. Another group of fossils are the hyolith with their cone-like conch, here one specimen with relics of soft parts preserved. And of course there are all types of microscopic skeletal particles such as hyolithellus tubes or chancellorioids here under F. These are very poorly studied and much more are still to be discovered. The Lemdat Formation is a geographically restricted succession of brownish, red and greenish marlstones and siltstones with thick limestones and dollostones interbedded and volcanic ash or volcanoclastic intercalations. The formation features somewhat different depositional conditions in the High Atlas during the interval in which the Igodine and the Amuslek formations were formed in the Anti-Atlas. This typical photo of the lower part of the formation shows a variable succession of black limestones, grey dolomitic limestones and green siltstones. As we will see, archeocyath bioherms developed in the upper part. This photo shows a close-up of the strata low in the formation. One character exists, however, which distinguishes the Lemdat Formation from coeval strata in the Anti-Atlas. There's a fluctuating but relatively high amount of intercalated volcanic tuff layers, such as the whitish centimeter-thick seam that runs obliquely through the middle part of this photo. Stromatolites are also known from limestone beds near the base of the formation. Particularly characteristic are columnar stromatolites as developed here. And this photo shows a big bioherm in the upper part of the formation with intercalated shales, having trilobites, so this enables a calibration of trilobite and archeocyath biostratigraphy. The archeocyath are partly marvelously preserved with lots of calcium microbe fillings in the voluminous interspaces. The archeos are still in living conditions but partly testified what was called a cavity dwelling. This is just another example of an archeocyan limestone, an original thin section by Françoise de Bren from her work from 1964. And here are a few trilobites from the Lemdat formation. The fauna still awaits a study of most trilobites, but these are all endemic, only known from this formation in the Lemdat area of the High Atlas mountain. The Isafene formation is composed mainly of relatively soft shales. Jean Schubert termed it the série schisteuse, and in fact it is subject to sometimes deformation to a sort of pencil slates in the western anti-atlas. The known thickness ranges from 26 meters in parts of the Tassenakt region up to 180 meters in the western anti-atlas. This is a view of the monotonous successions in the type area of the Isafene syncline, with aesthetic view due to its tectonic deformation in this narrow syncline. The succession was early recognized to provide not only a characteristic lithostratigraphical signature, but also to reveal a biostratigraphic significance characterized by a number of trilobites. In this aspect, it was one of the intervals used for UP's first biostratigraphic scheme for the Lower Cambrian. These trilobites are shown here, but it needs to be emphasized that this species of Antatlasia is not the species that UP had in mind. There are numerous other trilobites known from the Isafene formation, most of them with distinct biostratigraphic significance. Some of them are known from southern Spain as well, such as Delgadella, Andalusiana or Saucianda. However, it is recognizable that they represent a biofacies more or less restricted to shales, whereas different genera and species of trilobites are found in sandstones or limestones of the same age. During the last decade, the trilobites from the Isafene formation of the Isafene syncline became subject of fossil trade, with many species now turning up in the fossil shops. Most of them are complete specimens carefully prepared, but some are also prepared in a way that the posterior thorax and pygidium have somewhat been invented, fantasy morphologies. Don't trust all dealers, or better, their specimens. The Isafene formation consists predominantly of shales, but thin bioclastic limestone beds turn up in the upper part at some localities, and some larger calcareous mounds are found as well. This is a spectacular example of a huge archeocyath bioherm in the southern part of the Isafene syncline. Archeocyath have been studied in some detail. Again, here a typical example of an archeocyath microbial limestone, quite strongly recrystallized from the southern rim of the western anti-atlas. A particularly well-known mound is known from the northern rim of the western anti-atlas, where the rocks are quarried as the red marbles of Amagor. The walls of the Amagor quarry exhibit several aspects, such as the flank of a mound complex here shown in A, which is covered by reddish intermount shales. The top of a mount complex is seen in B, again flanked by reddish shales and capped by grainstones. And the flank of mount with plenty of par-autochthonous archeocyath debris is visible in C. There are also Neptunian dikes infilled with reddish flank sediments, partly occluded in calcite. This here is a sketch that explains the mount geometry at Amagor. The archeocyaths from this complex are also well studied and offer some characteristic and partly also endemic species. A conspicuous facies change occurred during the late depositional interval of the Isophyne Formation in certain areas of the western anti-Atlas. Typically, this is characterized by rocks termed the calcareous coriacea, translated into English as coriaceous limestone. These are purple shales with roughly stratiform calcareous nodules. The shales themselves are, as well as the limestones, have fossil remains, but they are fairly intact in the shales and usually fractured in the nodules. Some localities clearly indicate that a more regular bedding of limestone within the shales has been disrupted by burrowing activities. The calcareous coriacea facies is frequently also combined with sandy layers with feldspar crystals, and close examination indicates that these are water-lane tuffs. In fact, a number of localities yield thicker volcaniclastic horizons. Here we see the base of the Isophyne Formation in the Lemdat syncline, where an ash layer covers the top of archeocyath buildups and are probably responsible for the end of the bioherm growth there before they were covered by green shales. The upper part of the Isophyne Formation in the Lemdat syncline of the High Atlas develops into strata with considerable volcanic particles which persist upsection into the Tatelt Formation. One ash horizon of this Isophyne Formation in the Lemdat syncline has been dated to 517.5 plus minus 1.5 million years. The Tislit Formation can be regarded as a shallowest marine equivalent of the Igodine through Isophyne formations in the central and east-central anti-Atlas. It is a heterolithic unit of alternating red or purple siltstones and fine-grained quartz arenates with thick intervals of largely dolomitic carbonates. The siltstones are generally argillaceous, but range into fine-grained feldspathic quartz arenates towards the east. The most spectacular character of the succession here in its western part are massive dolostone beds. Body fossils are extremely sparse, and to date not a single of them has been determined to genus or species. Known are mostly simple trace fossils. Sedimentary cycles in the Tislit indicate extremely shallow marine depositional environments. The alternations include stromatolitic carbonates that are overlain by siltstones with crossbeds and ripples. Desiccation cracks point to a subaerial exposure. The top of the cycles are composed of shale with halite pseudomorphs formed under hyposaline conditions. The Isophyne and Tislit formations are overlain by a thick package of siliciclastic rocks, which have been first termed the Gray Terminaux, in English the terminal sandstones, because they were thought to terminate the lower Cambrian depositional succession. The unit has been renamed to the formal name Asria Formation, but subsequently it has turned out that this Asria Formation was in fact composed of at least 4 different formations. Shown here are the Agert, Taslaft, and Akerus Formation. The somewhat complicated situation for the lower part of the former Great Terminaux is sketched here. The formation with probably the largest area of distribution is the Tasslaft Formation, which prograded from east to west. The formation is a monotonous succession of pinkish, reddish or purple, locally green-gray, massive, cross-bedded and relatively well-sorted sandstones, which locally form massive cliffs and partly rests unconformably on Precambrian basement rocks in the eastern anti-Atlas. To be a little bit more precise, the rocks are generally purple or pinkish trough cross-bedded arkoses and feldspathic sandstones. They can be identified as tidal deposits which record a siliciclastic mudstone platform. These are bedding planes with oscillation and interference ripples, quite typical for the formation. These and other sedimentary structures record shallowest marine nearshore and tidal conditions with frequent subaerial exposure. Nevertheless, hummocky cross-stratified beds are also recognized. Only a few simple horizontal and vertical trace fossils as well as U-shaped burrows are recorded from the succession. One of the puzzling units is shown here in probably the best outcrop. It was introduced as a distinctive unit termed the Acarus Formation and is restricted to a minor area in the eastern anti-Atlas. Granulometric analysis and the type of cross-bedding suggested that the sandstone that composed the formation were deposited under terrestrial fluvial conditions. Similar exotic depositional conditions are recorded from strata that form the top of these sections at Agert, at the southern rim of the western anti-Atlas, and they are defined as the Agert Formation. The massive coarse-grained aaronites and conglomerates with trough cross-bedding are interpreted as deltaic deposits arriving from the south and intersected into the Tasslaft Formation. They reach only 10 to 20 meters in thickness. However, the recognition of these formations remains a bit problematic as it is based primarily on granulometric studies. Tasslaft, Agert and Acarus formations characterize the extreme regressive branch of the Grand Cycle, whereas the overlying, partly similar sandstone already featured the following transgression. This Tatelt Formation was dealt with as part of the Asri Formation as well. However, careful study clearly proves that the sandstones consist in part of particles of the Tasslaft Formation which were reworked and redeposited during this next transgression, which is clearly indicated by plenty of body fossils of a younger age in the Tatelt Formation. This photo shows a section in the Lemdatz incline in the High Atlas, with the Isaphane Formation at the very base of the cliff, overlain by the Tasslaft Formation, and finally the Tatelt Formation at the top, which is barely distinguishable from the Tasslaft in this aspect. Nevertheless, it needs to be emphasized that plenty of volcanogenic particles form a considerable amount of the Tasslaft and the Tatelt in this area. The distribution of the Tatelt Formation and the pronounced differences in thickness already indicate an exciting depositional history. Apart from being seemingly unattractive on the first glance, the Tatelt exhibits an appealing depositional history with several sedimentary cycles recognizable by its microstratigraphy. Changes in the rock colors exhibit such cycles as well as different trace fossil communities. These are cool border shoaling up cycles representing 4 parasequences. Summarized, 3 members can be distinguished. Only the upper one includes hummocky cross-stratification and reminds the facies seen in the upper part of the Tasslaft Formation. Here, in the red ellipses, the hummocky cross-stratified intervals resembling sediments from the Tasslaft Formation. This diagram shows a west-east cross-section through the formation, which reveals that the HDS-bearing strata prograde from the margin of the basin and coincide in its extension approximately with the distribution of limestone beds at the base of the overlying Jebel-Wabermast formation, which we will see in a few seconds. The Tartelt formation yields body fossils such as trilobites, brachiopods and mollusks, but usually in a fairly poor preservation, which is just a result of the sandstone matrix and the presence of easily weathering volcanogenic particles. The trace fossil spectrum is locally preserved and much larger than that of the Taslaft formation. Here you can recognize at least 5 different ichnogenera. What caused the regressive, transgressive development in the lower middle Cambrian boundary interval is a matter of ongoing discussion. As we saw, the differential subsidence and block folding during the early Cambrian in present-day Morocco created distinct differences in facies and thickness of the rocks. Nevertheless, there is no doubt that a pronounced global sea level drop took place at about the lower middle Cambrian boundary. This was first shown for an area in eastern North America, best known as the Hawk Bay, and this regressional development is therefore usually termed the Hawk Bay event. Unfortunately, the regressional transgressional sea level changes did not take part absolutely synchronously, so that the pattern cannot be transferred one-to-one between the paleocontinents. The Moroccan sea level changes started probably a bit earlier than those in most other regions, probably because of an interplay of eustatic and epeirogenic developments. What we can recognize in the high Atlas and in the anti-Atlas are the following facts. First, an uplift of certain areas and resulting denudations of these areas took place in the high Atlas during the latest early Cambrian. This was followed by a floundering of the areas in the western anti-Atlas and a reactivation of the Sus Basin deposcenter. 2 regional unconformities developed across southern Morocco. 2 marine onlaps developed during the latest early Cambrian, both associated with volcanism. The first of these marine onlaps is that of the Tartelt formation, with its cryptic unconformity at the base, not recognized by most geologists. The second is eye-catching and marks the start of a typical Middle Cambrian depositional regime. The probably most interesting formation in the Cambrian of Morocco is the Jebel-Wabermast formation, which covers a large part of the Middle Cambrian succession in parts of the High Atlas and Anti-Atlas. This photo shows the type section at the slope of Jebel Kisan in the central Anti-Atlas, with its lowest part in the foreground. The discovery of trilobites from the formation was probably done on this spot, from which this photo is taken. In 1933, Jacques Bondon collected fossils from here near the hamlet of Urikan Warmast from a bioclastic limestone, which later was called the Bresh Amikmaka. Among the specimens of his first collection was this cranidium of a trilobite, which was described as Kingaspidoides brevifrons by UP in 1953, one of the index fossils from the uppermost. This is a map showing the outcrop areas of the formation in red, indicating the enormous stretch of the formation. However, please keep in mind that most of the formation is covered in the east and eroded in the west. The Jebel-Wabermast formation covers a considerable area in the Jebel Ugnat region in the east, and the landscape there is to a large degree a result of the rocks of the formation, with the overlying Jebel Avro formation forming the top of the mountain in the left part of this photo. The lowest part of the Jebel-Wabermast formation is mostly characterized by limestone beds intercalated into the fine-grained greenish to yellow sandstones, and this part of the formation is therefore separated as the Bresh Amikmaka member, owing to the name for the first limestone bed described there. The number of the limestone beds developed varies considerably from 2 to up to about 7, and the microfacies of the limestones beds varies as well, typically being bioclastic stones composed primarily of trilobite and brachiopods sclerites. The limestone beds are just parts of sedimentary cycles. As the marine onlap advanced from west to east, so that by the end of the Jebel Warmas deposition, the Adrar Dren Massif in the western High Atlas was covered, and southern Morocco was completely inundated by shallow seas. The green to purple or red alternations of the Bresh Amikmaka member have a limestone cap with erosive base, and this suggests an interval of mesoscale onlap events with condensed horizons that are tempest tides at the top. However, depending on the paleorelief, the first or lowest cycles are not developed in some areas. The lowest of these limestones is usually the best developed and the thickest of the beds. It is often an amalgamated bed. The most spectacular of them is located north of Tizi Tel Ganj, shown here, a more than 1 meter thick bed consisting essentially of echinoderm ossicles. It is quarried there for ornamental stone, and I can only recommend to look for getting a slab of these rocks for your dinner table. The calcareous beds higher up in the section are less clean and include more and more reworked and limonitized clast. They belong usually to the ornamentaspis frequent zone, whereas the lower ones are typically in Morocconus noctabilis zone horizons. The fine-scale biostratigraphic resolution is ensured by an extremely good fossil record, mainly by the numerous trilobites recovered from the Bresh Amikmaka member. Most of the trilobite species are restricted with a range to about 1 zone, so that even a subzonal stratigraphy resolution is possible in highly fossiliferous sections. The photo on the right shows a mass assemblage of the eodiscid trilobite Morocconus notabilis, which is the index fossil of the eponymous zone. The trilobite on the left is a species of the genus Protolinus, which enables a relatively precise correlation into the continent Avalonia. Here are a few more photos of fossils from the notabilis zone. Particularly noteworthy are a species of Condylopaigi under D, which occurs in Spain as well, and which not falls into the uppermost Lower Cambrian and is thus one of the oldest Condylopaigi species worldwide. And an early Oryctocarid trilobite under G. And finally, under H is a brachipod shown, Trematobulus, which is occasionally found as monospecific assemblages and in almost rock-forming mass occurrences. Many of the trilobites developed into collector's items, and in the Jebel Ugnad region there are villages in which people earn a considerable part of their income with quarrying for such trilobites. The specimens on the right all show species of the genus Echedoparadoxides, which clearly indicates the paradoxidids formerly used as index fossils for the Middle Cambrian are present in this zone, albeit it now belongs to the International Series 2 and Stage 4. Admittedly, these are among the oldest paradoxidid trilobites worldwide. The trilobite on the left is a specimen of Echedoparadoxides briareus, the first of the commercially quarried Cambrian trilobites. This species is meanwhile on display in many of the natural history museums in the United States, the United Kingdom, France, Germany, Mexico, Japan, and elsewhere. It is also the largest known paradoxidid, and the specimen from a private collection in France is almost 50 centimeters in length. You would not want to meet this alive during snorkeling, and also not in your bath tube. The photo on the upper right shows a lateral view of a trilobite which was recently described. It belongs to the weird wonders, with its 2 big spines curved forward rather than rearward, as one would expect. The reason is a behavioral one, as the spines would otherwise collide during special modes of enrollment. Specimens of these species are also quite popular on the fossil market, but quite rare. The different preservation with a phosphatized cuticle already suggests another origin, and indeed, they come from the differently developed limestone beds of the ornamentaspis frequens zone. I have already talked about the limestone beds as being the result of sedimentary cycles, which are identifiable as porosequences. These slight changes in depositional environment are also reflected by rhythmic changes in the colors of the sandstones or shales between the limestone beds, starting with gray and green strata and turning into red and finally green just below the overlying limestone beds. The fossil record in the Brescia Micmaca member is dominated by trilobites, but other fossil groups are as well present and can be frequent or even abundant at some localities and in certain horizons. They include brachiopods, as the species shown in the upper right, echinoderms, shown on the left, and members of early mollusk groups such as the enigmatic Maricela myra and the strange hyolith Elatraca ugnatensis. Some localities are extensively fossiliferous, and they attain biodiversities which are among the highest known from the Cambrian in total, and particularly the horizons from this stratigraphic level. The top of the Tisintichka road formerly did cut a limestone lens of the Brescia Micmaca member with a tremendously diverse fauna, particularly hyolith, and more than 50 different forms have been identified from just this local horizon. A careful study of well-exposed sections enables to recognize the diversity and, to some degree, precise stratigraphical ranges of the species. This allows an extremely precise stratigraphic resolution so that subzones of the Morocconus notabilis biozone can be identified, as exemplified here for the Tarhusht section in the Jebel Ugnat area. This in turn allows a tentative reconstruction of phylogenetic pathways as shown here for the earliest species of Acadoparadoxides, which clearly have their origin in the region of the present-day Morocco. What is shown here are the shapes of the pygidia of the species next to their stratigraphic ranges. Paleoecological studies in general tend to compare faunal composition and base some conclusions on spatial and temporal changes on them. Well, examples from the Brescia Micmaca member at least suggest that such conclusions need careful considerations. Here I show some pie diagrams of the faunal compositions from a single highly fossiliferous section. The numbers simply refer to the stratigraphic position in meters above the base of the formation. The differences clearly suggest that the compositions vary considerably between short intervals, and transport mechanisms as well as local environmental parameters had a pronounced impact on what is preserved in the rocks. The part of the Jebel Wafurmas formation above the Brescia Micmaca member at its base is much less attractive and poorly studied for most part. The member immediately above the Brescia Micmaca has been termed the Tarhusht member in the center and the eastern anti-atlas, and is devoid of distinct calcareous beds. Its thickness differs considerably, and its top is quite differently developed. In the western part, the formation seems to persist through most of the Middle Cambrian or Meolingian. The stratigraphic range high up into the Middle Cambrian is proven by quite distinct trilobite faunas, which are imperfectly studied to date. These are some examples for trilobites from the Chemotaspis zone, which follows on top of the Ornamentaspis frequent zone. A typical cranidium of the genus Chemotaspis is shown in the upper left photo. These are typical trilobites from the Badolesa tenera zone, including quite widespread species such as the Hartella on the right and Badolesa tenera in the upper center, which are also known from Iberia, Germany, the West Avalonian regions of North America. Large articulate brachiopods are also frequent in some horizons, such as this typical endemic species Brahimortis antiqua from the Anti-Atlas. In the western part of the Anti-Atlas and the western High Atlas, the formation persists up into at least the Pardalhania zone, where trilobites and other body fossils become increasingly rare. The rocks turn progressively into green, more well-washed and often slightly siliceous siltstones until the Gibbelwauermass formation is truncated by an erosive unconformity at its top. In the central and eastern Anti-Atlas as shown here, the Gibbelwauermass formation is overlain by a more sandstone-rich unit termed the Giebel-Afrau formation. This formation largely consists of greenish to yellowish, fine-grained sandstone with intercalated coarser-grained quartz arenites. The quartz arenites exhibit a variety of sedimentary structures that include cross-bedding, hummocky cross-stratification, and channels. It has a maximum thickness of 400 meters at the margin of the El Guara Massif and 100 meters in the Jebel Ugnat area. It seems to represent part of the Drumian stage, but no index fossils are known, so that this age assignment is tentative. Above the Jebel Afrau formation lies another sandstone-dominated unit, the Rish Khalifa formation. The formation is poorly studied. It consists dominantly of resistant fine-grained quartz arenites capped by an often dark-colored bed of fine-grained conglomerate. The lower part of the formation includes generally more argillaceous arenites. Fossils are completely unknown. The formation ranges from 15 to about 75 meters in thickness, but difference in thickness are primarily caused by subsequent erosion. This photo shows the Rish Khalifa formation in the lower slope, overlain by Goodsongian or late Middle Cambrian strata, developed again as marine shelf deposits and known as the Bagliella formation. The latter unit, featuring a new transgression, is mainly composed of yellowish to ochre-colored or green shales and sandstone with occasional beds of sandy carbonate. Its thickness ranges from 30 to 70 meters in the studied section. The Bagliella formation consists of lower green shales that grade upward into fine-grained micaceous sandstone with a significant component of shell fragments and mud flakes. Numerous calcareous layers that include marley beds with shell hash or arenaceous calcareous nodules are present and create the banded aspects of the outcrops. A particularly common faunal element of the calcareous fascia is the name-giving trilobite Bagliella. This trilobite has been frequently identified as Bagliella levii, a species known from Spain and southern France. The specimen shown here in the upper left was collected by Jacques Bondon in 1934 as one of the first trilobites determined from the Anti-Atlas and was described as a new subspecies of Bagliella levii. It is occasionally accompanied by other trilobites such as species of Ctenocephalus shown below, a new paradoxidid genus, and even a genus of ellipsocephalid trilobites, which is the youngest of this family known to date. The upper part of the Bagliella formation yields locally a rich assemblage of ichnofossils. Here are examples for such trace fossils with funnel-shaped monocriterion type vertical tubes seen on a bedding plane here together with plenty of other poorly preserved traces, but also supposed arthropod tracks with nice loops. Here are some sandy or shaly intercalations in the upper part. Often they exhibit spectacular bedding planes covered with oscillation ripples. The Aslak Formation consists of massive sandstones with an upward trend from green, micaceous and chloritic sandstones to siliceous quartz arenates with herringbone cross stratifications and scolithos tubes known as pipe rocks. In sections where the formation has not been erosionally truncated, its thickness ranges from 50 to 70 meters. This photo shows a characteristic set of beds, with some developed as typical pipe rock with simple vertical burrows, often in great number. This is an example of such rock with the trace fossil Scolithos, which is characteristic for high energy environments in coastal settings. The uppermost and youngest Cambrian lithostratigraphic unit recognized in the Anti-Atlas has the name Gibbelmresma Formation, which sticks in mind at least because of its virtually unpronounceable name. The formation seems to be limited to the area between Has Ibrahim, Fumskit and Tasnakt in the central Anti-Atlas. In fact, the formation is only known with certainty from 3 localities in synclines of the central Anti-Atlas. This is probably a result of erosion in the later late Cambrian. Its thickness is usually around 35 meters and it is truncated at top. Most typical are dark greenish shales and sandstones as shown. However, the succession includes a variety of rocks. In addition to the soft, dark green shale, it has beds of argillaceous siltstone and fine-grained sandstones, often with abundant small mud flake clasts. The base of the formation is conglomeratic or cross-bedded. Such sandstones are often strongly limonitized. Most conspicuous are thin, rarely quite thick calcareous layers and calcareous nodules, which yield some fossil fragments. Few fossils and few sedimentary structures are known to date from the shales and the sandstones. Here we see the remains of a complete dorsal exoskeleton of a trilobite in quite a poor preservation. Nevertheless, the calcareous beds are of particularly interest. They are generally composite beds with record different depositional histories. This here is an example of such a limestone which is partly burrow-churned and shows a big tachygnous burrow. The upper levels in 2 of the limestone beds yielded some fossils, mainly trilobite sclerites of relatively poor preservation. These assemblages include a posi-specific fossil assemblage with the trilobites Olentella, Celatella, and the brachiopods Sacogonum saccatum and Billingzella. They prove indeed an early late Cambrian age of the Pibean stage. And this completes our long journey through the Cambrian of Morocco. This is a farewell photo of my amateur colleague Tony Vincent from Aberdeen during field work having fun. Here a farewell photo of my colleague and long-term collaborator Ed Landing from New York State in one of the synclines of the central Anti-Atlas, rolling home after an exhausting field day. I'm hoping you are less exhausted and will keep at least a few facts in mind. Here a few hints to my early collaborators, to which I'm more than grateful. Thank you.